Hi, today I will explain you the Fibonacci number and Fibonacci series. Fibonacci number is a number where the zeroth number is 0 and first number is 1, and after that every n greater than 2, every from greater than equal to 2, every number equal to n my Fibonacci n minus 1 plus n minus 2. So Fibonacci 3 will be 0 plus 1 1, then Fibonacci 2 will be 0 plus 1 1, then Fibonacci 3 will be 1 plus 1 2, then Fibonacci 4 is 1 plus 2 3, and it will be go so on. And it is very important in mathematical number, because when Fibonacci numbers go to infinity, that ratio of n and n minus 1 is called golden ratio, which is used in many mathematical function. And also, like when you are modeling diffusion or modeling gossip, then one person is talk to two, then this two person will talk to three, more two. In this way, it will be go in this Fibonacci, according to Fibonacci sequence. So there it is also useful. Now, the for simple implementation of the Fibonacci number, I will implement it. Show the implementation in Python and Java. So first simple implementation is using recursion. So n equal to 0, it is written 0, n equal to 1, written 1, and above that it will be written n minus 1 in the n minus 2. So it will be run fine for value equal to 10. So it is giving the value at 10. But the problem is that, so let's show the Java implementation. So it is also the similar thing. Okay, so run. Sorry. Uh, 10. So this is Java, so it is Fibonacci 1. So Fibonacci 1 is the implementation of the Fibonacci number in recursion, using recursion. So that is the function. So it is, but the problem here, if you give the value to 100, you don't get any result, because it will throw exception. Why the exception happens? Because when you are calling a function, it will require the stack, and it is iteratively calling function again and again, and so it will record huge stack memory for the number like 100 or 200, and then it will give the exception. So you run it, it will never give you the result. You see, there is no result. Because it is get the stack overflow exception. So here also you see that there is no result. Okay. No result, because it will give the stack overflow exception. So what is the solution? So one solution is using, so for this kind of problem, you have a dynamic programming based approach. So dynamic programming based approach is like something like that. Okay, so you see this job get exit, but without printing again. So it is the so you are keeping an array of n plus 1 size, and from 0 to 1 you calculate the number without any recursion, but storing the value in the array. So so it will be give the you the result for the 100, you think. See, and one interesting thing that here I am storing the array in the long, storing the value in the long value, because Fibonacci number like 100 will be very big integer, so it cannot be stored in the int variable. You will need the long variable for that. And Python, you don't have this kind of strictly type variable, so here you don't need to declare anything like long. It automatically convert when the value will be longer, it will be automatically calculate the longer value, convert it to the long integer. So you see here it is also the in the array we are creating an array of n plus 1 size, and so you see here it is the result is coming. It is a very big integer. But it is also the space complexity of the problem is n plus 1. So it is a huge, so it is for a huge number. So here also it is giving the answer. But space complexity of the problem is n plus 1, because you are creating an array of n plus 1 size. But we don't need to store all this number to calculate the Fibonacci number. We need the only last two numbers. So there is a more intelligent implementation of the Fibonacci number, where you just store the last two number and update it every time by the first number by the second one, and second number by the result. And in this way you can calculate, and your place complexity will be lesser. And it is the most optimal. So here in the Java also you see the same. And this F0, F1 result should be long, otherwise it cannot store the value. C3. So you run. And here the space complexity is just order of 1. So you have some constant variable, that's all. And time complexity you cannot reduce more than n. So you see here, and also you see, I don't see V3. So it is the result. So that's all. Okay, now that's all for today. So it is 10 minutes. I finish it in the 7.3.30 seconds. So that's all.